Yes, this was the again the syllabus. Um, we have more or less uh, covered the syllabus. Few things maybe here and there, but that is not the very really big issue. What is basically this class all about? That if you have any doubts about whatever has been taught till now, you can tell me. Already, I have one request that to cover the solid phase. Is it uh, solid phase peptide synthesis and the nomenclature system of peptides? Was that the request from I forgot the name? Yeah, who requested that? That solid phase peptide synthesis. Shiny, is it? Shiny Banerjee. I think I got a mail from you, right?
Yes.
Yeah. And what was your request? That to
This peptide synthesis.
solid phase peptide synthesis, and also there was this nomenclature system or
Yes, the nomenclature.
nomenclature. Okay. Mm, just a second. Let me put some bad blank slides. Okay, solid phase peptide synthesis. What was the idea behind this? The idea behind this is that you have a solid bead where there is a functional group which is attached. Okay, like in Merrifield, there is a different beads or resins available. The simplest one is what is called Merrifield, the Merrifield resin. Merrifield resin. Merrifield resin had a functional group in the bead. See, basically, it is a what is called it's a chain. It's a carbon chain, and there are phenyl groups hanging from the chain. And some of these phenyl groups have a chloromethyl group. Not all. Maybe this one will not have, but then there may be another one where there is this CH2Cl. Okay. So let us stick to a particular bead with one arm, which is the chloromethyl group. Okay. So here what is done? The first step that is done is the you have to attach the C-terminal amino acid, the N-protected C-terminal amino acid. That means there are in the peptide, there are two terminus, okay, unless it is a cyclic one. Cyclic one does not have any terminus, but if it is acyclic, then you have say X is one amino acid, Y is amino acid, see Z is another amino acid. So this is a tripeptide, and the way of writing says that X will have the NH2 free, that is what is called the N terminus, and Z will have the carboxy free. So that is called C terminus or carboxy terminus, and this is the N terminus. Okay. amino acid. In this case, when you are doing solid phase peptide synthesis, first you have to attach the Z, that is the C terminus amino acid. So an amino acid is having two functional groups, CO2H and NH2. In addition, it may have others, that is depending on the nature of R. Sometimes R has another NH2, or R may have a WH or SH. So, but these are the mandatory functional groups that are present in the amino acid. Okay. So first step is that you have to take an N protected. So this is basically your Z. You have to pick up the Z amino acid, which is I am representing it in this form, and you have to protect the NH2. You have to protect the NH2 with some protecting. Okay. And then attach the carboxy group. The carboxy group, and this is a very reactive halogen because it is a benzyl, it's a benzylic chloride, which is extremely reactive to SN2 displacement. So the carboxylate anion, if you can generate, that will come and attack this carbon, and this goes out. Okay. So that results basically, that results what? That results in the, that again, suppose the bead is here, and the Cl is now replaced by O, CO, and then R, and you have NH with a protecting group. Okay, you have to protect the NH because otherwise this NH would have also displaced the chlorine. So there will be competing reaction. Either carboxy or the NH would have displaced the chlorine. So NH has to be protected so that it does not react. So this is the first step. The second step is what? You have to take the protection, the protecting group up, so that is deep protection. So if it is deep protection, then you have CO, O, this is your resin, and you have R, and you have NH2. Now you add the other, now the middle one, the Y. Okay, the Y should have which one should be free, the carboxy or the NH2? Which one should be free when you add the second one? So this is your Z amino acid, this is your Y amino acid. I am putting R1 here. So naturally it should have CO2H free. So you have to couple these two, and this one should be protected. Again, you should have an NH protected amino acid. Okay. So what is your next step is what is called coupling. So you have to couple this NH2 and CO2H. So that is coupling. Okay, let me go to the next page. So again, I write what I have written here. So CH2Cl, now that is replaced by OCO. This is your R. This is your NH2. You have deprotected that, and you have to couple that with the second amino acid from the C terminus. The second amino acid from the C terminus, but your NH has to be protected. So you have this, you have, this is what is called coupling, and you have NH, R, sorry, NH, and then it will be NHCO. This is the peptide bond, and then you have R1, you have NH protection. So then again deprotect this one, you have to take it off and repeat it with the X amino acid now. Okay, because that is your Z amino acid, this part. This is your Y amino acid, So the synthesis is going actually along the reverse direction. You are actually making Z, Y, X, and Z is connected to the resin. Okay, so now you have to just again repeat the steps. You have to deprotect. So this will be free. So again O, CO, R, this NH, CO, then R1, then NH2, and you have to now add the amino acid. In fact, that is the first amino acid from the N terminus. X is the first amino acid from the N terminus. So that again that should be free. The carboxy should be free, and NH2 again NH should be protected. And now you put a different R group R2 and do the coupling. Okay. So basically what you have, this is the resin, Cl, O, CO, R, NH, CO, then R1, then NH, then CO, then R2, and then NH protected. Okay. So now now your synthesis is complete. You don't have any other amino acid to add. So you deprotect. You have to write complete deprotection. Complete deprotection. That means you take this off from the resin and you also take the protecting group off, and that will give you the so again remember, this is your Z, this is your Y, and this is your X. So you will get your Z, Y, X, but this has got free NH2 and this has got carboxy group. Okay, so it is basically written in the opposite direction. In convention, according to convention, we should uh, write this in this fashion. Okay, the N terminus should be to the left. So basically, what is some points have to be noted for solid phase peptide synthesis. The most important point is that it starts from the reverse direction, that means from the C terminus end. On the other hand, in solution phase you have both flexibility. You can start from the C terminus end, you can start from the N terminus end. There is no limitation. Here the point to note is that it starts from the C terminus end. Okay, and if I ask you now, we have just stated the protecting group, coupling agent, coupling, deprotection, and all these. So now the next question is, for a particular example, if I give you a particular example, that then you have to also give me the information that what should be the protecting group on the amine. That when I started with Z, where the Z, the amine group is protected. So what is the nature of this protecting group? What is this P? Can anybody tell? What is the P? What type of protecting group I should use? Anyone, just tell some protecting groups, we will find out which one is the best.
Sir, Bach.
Bach, okay. So, uh, basically, yeah, Bach is okay. Now, if I reframe the question, that if what are the protecting groups on nitrogen which or name one protecting group for the amine which comes up with acid, which comes up with hydrogen, and which comes up with piperidine. Okay, so Bach, we know that comes up with acid, huh? Then with hydrogen, what comes off? Which group? Which protecting group comes up with hydrogen? What other protecting group you know apart from T-Boc for the amine group? Other than this, what is T-Boc? You have, if you have NH, then you have CO, then you have O, then you have T-butyl. That is your T-Boc, right? Basically, Boc group is this one, COO, this. T-butyloxy, what is the full name of T-Boc? Can anybody say the full name of T-Boc? Full name of T-Boc. Anyone, just tell me, try what is the full name, because we have to know the full name also. Otherwise, later on, other protecting groups may make mistake. Yeah. What is the full name?
Tertiary butyl oxycarbonyl.
Okay. Tertiary butyl oxycarbonyl. Similarly, there is another group where the T-butyl group can be replaced by a benzyl group. That means NH, CO, O, CH2PH. So what will be the name according to this? This was tertiary butyl oxycarbonyl. This is benzyl oxycarbonyl. This is benzyl. So this is benzyl oxycarbonyl. It is actually not. It is written in again the name is like this, CBZ. Now here they don't follow the same type of abbreviation like T-butyl oxycarbonyl. Here it should have been what? Benzyl oxycarbonyl. But the problem is if you call it benzyl oxycarbonyl, maybe it will look very similar, means abbreviation. Benzyl oxycarbonyl. So to avoid that, what they have done, they have said that this is carbobenzyl oxy, CBZ. There is a carbonyl, so you can say carbonyl, but okay, that is like the full name, carbonyl benzyl oxy, carbonyl benzyl oxy, or you can, this is abbreviated as benzyl oxy. Carbo means actually carbonyl, so it should be carbonyl benzyl oxy. That means they are naming from the reverse direction. Earlier it was T-butyl oxy carbonyl, T-butyl oxy carbonyl. Now carboxy carbonyl benzyl oxy. Carbonyl is this group, benzyl oxy, but that is abbreviated as carbobenzoxy or carbobenzyl oxy. So that becomes CBZ. So this is, but structurally it is very similar. This is NHCO T-butyl, this is NHCO benzyl. Now this is the group which comes up with hydrogen. You remember I told you that this is the group that comes up with hydrogen. This is the group which comes up with acid. And which group comes up with piperidine? Which group comes?
FMOC.
F
MOC.
FMOC. Yes. What is the full name there? Again, the full name. Or
Fluoronyl methyl
yeah,
oxycarbonyl.
good, good. Fluoronyl methyl oxy carbonyl. So this is CH2 and then O, and then it is the same O NH, and this is the amino acid. That means NH, we can write it in the reverse direction. NH, CO, O, and then this whole thing. This is a 5-membered ring. This is also a 5-membered ring. So this is what is called F mock. F mock. I think maybe it is F mock. M is small. Okay. F mock group. Okay, that comes up with base. Which one is usually used for solid phase peptide synthesis? Which one is generally used? You can use T-butyl. T-butyl comes off with acid. Okay. And the amino acid which is stuck to the resin, from the very beginning, that also comes from the with acid. That also comes with acid. Just a second. Hello. হ্যাঁ বলো. হ্যাঁ 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 ঠিক আছে. আচ্ছা, না না স্কাইপ না, দূর, হ্যাঁ গুগল মিট কিছু একটা পাঠাবে. ঠিক আছে. আচ্ছা আচ্ছা, দেখা হবে. হ্যাঁ হ্যাঁ ঠিক আছে. একটু এনকারেজমেন্ট দিতে হবে. হ্যাঁ হ্যাঁ ঠিক আছে. আচ্ছা. হ্যাঁ. So the resin, the amino acid can be taken off from the resin by acid. Okay. So it will be better that when you finish your peptide synthesis, whatever the number of amino acids, you should have an acid level protecting group here, and this one is the resin that comes off with acid also. So the last deep protection should be completed in one single step. So this protecting group should be what? That means the amino acid, this is the which amino acid at this end? Is it the C terminus or N terminus at this end? Because it is solid phase, so this is your C terminus, and yes, this is your N terminus. Okay. So, and this is your C terminus. So the N terminus amino acid should have a protecting group which is acid level, like BOC, so that both these groups can come off with an acid. Usually at that point HF is used, hydrofluoric acid is used. Okay, so that both the groups come off at the last stage. In between that, when you are doing again I write this peptide X, Y, Z. So you started with Z, that was linked to your bead, and Z amine is protected. Then you have to take this protecting group off and then couple that with, so one is deep protection, and then second is you have to use Y now. Y with carboxy free and NH protected. Okay. So my question is, now what type of protecting group should be used here regarding P? What type of protecting group I should use for Z and for Y? For X, I am sure, because X should have a protecting group which comes off in acid, because that is the N terminus. Then the characteristic of this protecting group matches with the characteristic of the bond which comes off from the resin. So that too we have to match. So this is usually the T-BOC that comes off with acid, and this is attached to the resin. In between, you have to use other protecting groups, which is attached to for the protection of the amine. So what type of protecting group will be this? For solid phase, what is used here? FMOC is used. These are usually FMOC amino acids. Okay. Uh, I, I hope you are understanding again. Say, take one particular example, say valine, alanine, and then glycine. So I ask you to synthesize this. So what will happen? You have to take glycine. What is the structure of glycine? Just CH2. So glycine, first step is glycine attached to the resin, and the glycine NH2 should be protected. This is usually protected as FMOC, because just to avoid, you cannot use acid. You should not use acid because you don't want to disturb this bond. This bond to be cleaved from the, and that is cleaved by acid. So better use a protecting group which comes off with base, which is just the opposite of the acid. Okay, so use FMOC. So you use you can deprotect with what? Piperidine. Sorry, piperidine. Spelling is this, or piperidine, is it? No. Piperidine. I think PI, piperidine. Piperidine is just a pyridine which is reduced. So with piperidine, this comes off FMOC. Okay. So in between, the amino acids should have FMOC group. Okay. One CO. So glycine, now NH2 is free. So you add what? Now alanine you have to add. Okay. What is alanine? Alanine has a CH3, and this should be free, and that should be again FMOC. Okay. So you get OCO, NH, and then CO, and CH3, and then NH, FMOC. Then you take the FMOC off. Again, deprotection. Okay, deprotection, the FMOC comes off. And finally, what you have to use, the final amino acid should be protected as BOC. And sorry, NH, there was OCO, or glycine. There is one CH2 here. CH2 and CH2NH, and then NH, CO, and then CH3, alanine, then NH2, and now you have to add the valine. Sorry, now you have to add the valine. Last is the N-terminus amino acid. What is valine? Valine is isopropyl. This is C. This has to be free, and this should be protected. Now this protection should be not FMOC. This protection should be T-butyl. Okay, so you can say just BOC, NH, BOC. Okay, so final. So now you have this resin, the glycine as attached, then the alanine, methyl, then the valine, isopropyl, and NH, BOC. So final step, you can just add your HF. So both this becomes free. So you have CO2H, glycine, this is NH, CO, this is CH3, NH, CO, this is isopropyl, NH2. But the name of this compound will be, according to convention, should be valine, alanine, and valine, alanine, and glycine. Okay. Any problem now? Is it clear that the important thing to note is that the amine groups in between the the amine groups which are inside the peptide, okay, that you can have F-MOC protecting group. But the last amino acid should have, that means the N-terminus amino acid should have a BOC protecting group, so that you can cleave both the bonds from the resin as well as the amine at the N-terminus. You can free it with one step by adding HF. Okay. Now let me ask few more questions. How do you ensure that when something is attached to a bead, that means the reaction is taking place in a heterogeneous media? Okay. So there are like marbles, and these marbles, the reactions are going on these marbles. Okay. So when you are doing deep protection, how do you ensure that the deep protection is complete? How can you tell? Because all these are reactions. Every reaction has to be given certain time, some temperature, some particular solvent. These are what are important. So basically, how do you ensure that your F-MOC group has come out when you are adding piperidine? I told you that. Can anybody tell me what is the mechanism of F-MOC deep protection? What is the mechanism of deep protection of F-MOC? Just tell me, I will write. What is the mechanism of deep protection of F-MOC? This is what is F-MOC. Fluorinyl, fluorinyl, methyl, oxy, carbonyl. Okay. So what is the mechanism of deep protection? That this hydrogen, you remember? Yeah, can you tell me, can anybody tell me what is the mechanism of this deep protection? What you have added is a base. Piperidine is nothing but a base. Okay. It's a mild base, just to avoid racemization of the amino acids. Okay. So what is the mechanism here? Can anybody tell me that what is the first step? Or what is the final? This comes as NH2, this comes as CO2, and this comes out as, because this is the base that takes this hydrogen out, pulls the hydrogen, that comes here, that goes there, and this takes up a hydrogen. So this is the mechanism. And the end product is the free amine plus CO2 plus this. This is, you can actually measure the UV, you can measure the absorption of light for this compound, and then you can calculate what is the concentration of this, and from that you can make out whether the F-MOC group has completely come out of the resin or not. That is one advantage of F-MOC, that you can always measure. Okay. Achha, maybe the more general question, if I ask that if I have solid phase versus solution phase, what is the advantage of solid phase over solution phase? What is the advantage of solid phase over solution phase? What is the most important advantage? Yes, anyone? Tell me, what is the advantage? Tell me something. Anyone who is there? Let me see. If I come out of this end slide, okay, let me stop sharing and I share a white screen. Okay, I share the white screen. What is the advantage of solid state peptide synthesis? Anyone of you? I could see 4 students attending the class. Any one of you give me an answer that what is the major advantage of solid phase peptide synthesis versus solution phase? Yes, Shiny, tell me what is the advantage? Are you there? Who is there? Shruti Datta? Are you there? Are you there? Lina Priya, LP? Can you hear me?
Yes, sir.
Yeah, so please respond. Otherwise, I may think that nobody is there. It is just turned on. So, what is the advantage of the solid phase? It is purification. Purification is the greatest advantage because here purification is that everything is attached to the bead. So you have to wash the bead, wash, and that will take care of all the impurities that are surrounding this bead. Okay. Only one component is attached to the bead. So purification is the greatest advantage. Okay. Second good advantage is that you can always use excess of reagent. Excess of reagent can be used so that the reaction goes into completion. You know La Chatelier principle, na? That how to make a reaction go to completion. That if you have A plus B and you are making C, if I want to completely consume A, so I will use excess of B. I will use excess of B so that it reacts, so that A completely reacts to give the C. So in the mixture, I will have C plus excess B because I have used excess B. But because C is in the solid phase, so just taking this off is not a problem because it is in the solution phase. So you can always remove the excess reagents very easily. So any impurity, excess reagent, everything can be taken off very just by washing. You don't have any chromatography to do. Okay. So that makes it very easy, and it is extremely useful for making long peptides. So where was your confusion? Shiny, where was your confusion for the solid phase?
Sir, I was not there when this was taught, and that was the major confusion. Like, I was
Oh,
unable to get it
now
through
it,
the.
now it is clear that how do you do? It is same like the solution phase. Only thing, the carboxy terminus has to be, it started from the carboxy terminus and slowly you go to the N terminus direction. Okay, that is the most important point. Many students make mistake because here if I ask somebody to synthesize this by solid phase, then they might put the alanine here first in the solid phase and then glycine, but that actually gives me glycine alanine. That actually gives me glycine alanine, right? Because this is the carboxy end that has to be hooked up into the bead. So it starts from the reverse direction, that a peptide with carboxy end that has to be attached to the bead, and then the synthesis started this way, proceeded this way, right? So that is the important part. Okay. And where was your nomenclature thing? You said nomenclature is a, which nomenclature? This nomenclature you wanted to ask something or some confusion you have? What type of confusion? Because that will make me understand where is the problem.
But
Yeah.
every question in the assignment that you gave, and I was not very confident while answering that. So I thought maybe
Now you are confident, or where is that question? Let me try to find out.
yes.
You have that question with you.
So not right now. Like that is in the files you
Okay,
upload.
that is in the list. Okay, just a second. So I think I can retrieve that. No?
Yes.
I can retrieve that question uh, here. Is it in the files? No? In the files, let me assignment, this one. Huh? Okay, let us go through this, the whole exercise. Then you will be able to tell whether everything is. I think that is one good way of getting into this. Okay, so which assignment? First tell which problem we should number. Which number? 5, 6, 7, 8, 9, 10, 11. Actually, there are 11 problems. So which one you are talking about?
So fifth.
Question 1. Question number.
Question number 5.
Question number 5. Okay. This one. Oh, question number 5. Identify the correct name for the following peptide. Identify the correct. Oh, this was a mistake there. There is a There was a mistake here. See, NH2. NH2 is missing. I didn't realize. Yeah, sorry for that. There is a mistake. That should be NH2.
Yes, sir. We
Yes,
considered
sir.
that. We considered that already.
Yeah, you consider that. So if it is NH2, then this is uh, now the problem. This question is whether it is L or it is D, because there are these centers, nah, the chiral centers. This does not have any chiral center, so we can always uh, first of all, this is written in the correct way. That is the N terminus here, which is free, and the carboxy terminus here, which is free. So I can always tell that the last amino acid, is it edit document? Yes. Is it possible to write? No. Open in desktop app. So actually I cannot write it here. That is the problem. Uh, does anybody know how to write here? Open in desktop app. Yes. What does it say? No, not this one. You can close. All done. Close this. Try launching the Microsoft Word again. Oh, they are signing and all these things. Anyway, let me just see it again. What I am saying that this is now glycine. There is no problem. At the end, it is glycine. Actually, all the answers have the glycine here. Where glycine does not have any L in front. Glycine does not have any chiral center. Okay. So the last one is glycine. So this one is out. Answer C is out. Okay. And so this will be what? This is the alanine. So at least forget about the L and D configuration. This is alanine, phenylalanine, and glycine. So we say that alanyl, phenylalanyl, glycine. So where are those names? Alanyl, phenylalanine, glycine. This one, alanyl, phenylalanine, glycine. This one, this is incorrect. Alanyl, phenylalanine, glycine. Also, now it is important to identify the configuration here, whether it is L or D. So you have to tell me whether this one is L. Can you see the arrow? Can you see the arrow? Yeah.
No, sir.
You cannot see the arrow, no? Okay. Let me go to this one. Let me write it, whatever was there. So now you can see whatever I am writing.
Yes, sir.
Okay, NH2. Then there was this alpha CH3. Then there was this CO. Then NH. Then there was this alpha CH2PH. Then there was again CO, NH, and glycine. Okay, the question is whether this is L or D. Can anybody tell whether it is L or D? Quickly. What is D or L? What is DL nomenclature? That if you draw an amino acid in the Fisher projection with the carboxy at the top and the alkyl group here, then if the NH2 is on the right, that is called D. If the NH2 is on the left, that will be called L. Okay, so that is the DL nomenclature. The problem is, if you can write Fisher projection and then see how it goes, rather than doing that, because that is a lot of work, rather than doing that, you can always think of this way, that determine RS, all amino acids, remember, all amino acids, all L amino acids, okay, except one, except cysteine, that means the sulfur containing amino acid, are has S configuration, right? All L amino acids has S configuration. Let me see whether that is correct or not. L amino acids means NH2 on the left, carboxy on the top. This is R and this is H. So number 1 group is this one, number 2 group is this one, and number 3 is this one. So this is 1, 2, 3. Looks like R, but the hydrogen is actually towards you in the Fisher projection. So that is basically S. So all L amino acids, remember that, except cysteine is S. In cysteine there is slight problem because there is a change in the priority sequence. So what happens? Cysteine is this, CH2 SH. Okay. Now if you do priority, this is 1, but that becomes 2. Carbon attached to sulfur, carbon attached to oxygen. So that becomes 2 and this becomes 3. So cysteine becomes 1, 2, 3. Hydrogen is in the horizontal direction, means it is towards you. So you have to change whatever you are seeing. So you are seeing anti-clockwise, but actually it is clockwise. This is R cysteine. So if that be the case, then you can make it easily. Just check whether it is R or S. See, this is 1, this is 2, and this is 3. So 1, 2, 3 looks like clockwise, but you have to see from the side opposite to that of hydrogen. So actually this is, according to RS nomenclature, this is what? R or S? Can anybody tell me? This is R or S. This carbon, yes, A or one more.
R.
Huh?
R.
This is R. This is R configuration. You think this is R configuration because 1 to 2 to 3 is clockwise. But remember, you are seeing this from the top, from the side of the hydrogen. But what is RS? In RS, you have to see from the side opposite to that of the hydrogen, means the group of fourth least priority. So if you see from the top, it goes like R clockwise, but actually when you see from the back side, you are supposed to see from the back side. So that should be not R, that is S. Is it clear to everybody?
Yes, sir.
Yeah. See why you said R, because you didn't realize that I am seeing from the side of the hydrogen. Because RS nomenclature has to be viewed from the side opposite to the group of least priority, in this case hydrogen. So this is S. That means this is L. Okay. What about this one now? Again put the hydrogen. You tell me whether it is R or S. Anyone? Whether it is R or S?
The R.
This is R, correct. This is R because this is 1, that is 2, and that is 3. Looks like S, but because you are looking from the side of hydrogen, you have to, if you see from the back side, it will be clockwise. So this will be R. So that means this is L configuration. What about this one? This is D configuration. So the complete name of this compound will be L-alanyl D-phenylalanine glycine. Is there any option like that? Can we
Yes.
check? That there was an option like that, right?
Yes.
So that is the, so whenever such nomenclature problems are given, first check whether it is written in the correct form. Correct form means that the NH2 on the left side is free and carboxy on the right side is free. So identify that, because I can always write in whatever direction, but ask you to name it properly. Suppose I write something, a glycine with a CO2H here, then I have alanine, okay, and then I have, say, uh, phenylalanine with NH2. So what will be the name of this compound? What will be the name of this compound? We are not giving L and D. That issue we are not bringing here. We are just giving the amino acid only, not the configuration. So what will be the name of this compound? Actually, I should not have this. This looks like that there is a methylene here. Direct attachment. Okay. Glycine, CO2H, alanine, phenylalanine, NH2. What is the name of this compound? Yes. Please come forward and tell. Any one of you. This is important. Actually, this creates some impression in the mind of the teacher. If you answer more, uh, so during gradation, that counts. The impression of the teacher about a student. So come forward and tell what is the name of this compound. Anyone? It may be the same student all the time. That is also okay. What is the name of this compound? Full name? So yes, let me call. JD, you are there? JD, are you there? SD, are you there? SD, LP, are you there? SB, are you there?
Yes, sir. But
Okay.
also
You don't know the name of this?
no, sir.
No. Like the previous way. First, see, this will be what? Either glycinyl, alanyl, phenylalanine, or it could be, see, this is not correct. What I am mentioning is that this is written in the wrong way. This is the carboxy group. So when you name it, you have to start from the N terminus end. So the correct name is phenylalanine. Then alanyl. Then glycine. So this is the correct name. Yes, you want to say something?
No, no, sir.
So you understood the point. That is what I was trying to make. That I can give you a problem writing with the C terminus on the left side. Okay. But when you name it, you have to name it from the N terminus end. Okay. That is, you should remember. Okay, let me see whether other problems are there. Where was that?
And we discussed question number 3 in the same assignment.
Yes. Question number 3.
Yes, sir.
Which amine is most basic? Which amine is most basic? Okay. Achha, first of all, um, again go to that whiteboard. Uh, See what happens. This amino acid, there is see this point this is alpha amino acid, right? CO2H, and you have a R group. This is the general structure of an amino acid. So if I compare an amino acid with an aliphatic, just a common, say acetic acid or propionic acid, CH3, CH2, CO2H. Okay. So if I compare the pKa of this versus this, the question is which one is more acidic? What happens actually, uh, usually acetic acid has a pKa. pKa of acetic acid is about 4.7, so far as I remember, of acetic acid. That means CH3COOH. Okay. Now in this case, what will happen? That in acidic medium, that means pH below the pKa, this will be present as NH3 plus. This will be present as NH3 plus, which is electron withdrawing group by inductive effect. This becomes an electron withdrawing group by inductive effect. Okay. So what happens to the strength of the carboxylic acid? That basically the general question, if you have RCO2H, if R is electron withdrawing, will the acidity increase or decrease? If you withdraw electrons, will the acidity increase or decrease? Yes. Tell me what happens.
It will increase.
It will increase. It will increase definitely, because this is, you are actually releasing what? You are releasing hydrogen as H plus. Okay. So the more you pull electrons in this direction, so the H will be lost more easily. On the other hand, if R is donor, then acidity will decrease. Acidity will decrease means pKa goes higher. Acidity increase means pKa becomes less. Okay. So at least we can compare now these two. Compared to an aliphatic acid, amino acids have a lower pKa. Lower pKa means it's a stronger acid. Why? because of this electron withdrawing effect, inductive effect of NH3 plus. Okay. Now the question was actually the basicity, because amino acids have also a uh, basic group, little bit higher pH. The amino acid will be present as this, na? CO2. At deuterion it will be present as NH3 plus. No, maybe okay. Let's uh, so as you increase the pH, first at low pH amino acids present as this. Then as you increase the pH, what will happen? It will lose the hydrogen, CO2 minus. Then as you increase the pH again, so this is your pKa, and then the pK, other pKa, that means this release of this hydrogen, this gives the other pKa. Okay. Now if you compare this with a just an aliphatic amine, suppose this again propylamine, and then do this experiment that I increase the pH, ultimately this is going to lose the hydrogen. So the question is, which one will be easier to lose, this one or that one? Actually, there are two ways of looking at this. If this is complicated, there is a very simple way of looking at the basicity of amino acid. See, basicity of amino acid is, don't go into any deuterion or all these things. You just write this structure. This is the simple structure of an amino acid. Okay. So without going into all these intricate details, you can say, what is this NH2 group? Nitrogen is more electronegative than carbon. So there is inductive effect here. So the carboxylic acid will be more acidic. What about the carboxylic acid itself? That is also an electron withdrawing group, because you have the carbon, then carbonyl, the carbon is attached to oxygen. So that is basically withdrawing electrons, creating a positive charge here. So that will now withdraw electrons from here. So this is also an electron withdrawing effect. Okay. So what will happen to the basicity of this amine? Okay. Whether the lone pair will be more available or less available towards donation to hydrogen. Again, I repeat the question. See, if you have an NH2 which is attached to an electron withdrawing group, and if you have an NH2 which is attached to an electron donor group, in which case it will be easier to add, or easier for the nitrogen to donate the lone pair to a hydrogen, because that is what is basicity. Basicity is basically ability to react with the hydrogen. Yes.
So when it is attached to the donor.
When it's attached to the donor, the basicity increases.
Yes, sir.
Right? Increase of basicity means what? How basicity is defined? pKb actually is the value which gives you basicity. Okay. Here students make a mistake. See, I can say pKb of this molecule X and Y. pKb of X is what? Less than pKb of Y. Because lower these values means the easier is the process. Like acid, pKa of, if pKa is lower than another pKa, that means this is a stronger acid than this one. Similarly, for pKb, if pKb is lower for one compound as compared to the other, so pKb is also the compound with lower pKb will be more basic. Okay. Interestingly, if something has lower pKb, so that will be similar as saying that it has got higher pKa. See, when I talk about basicity, Basicity is actually measured not by this, measured by this equilibrium, that NH3 plus, if I add H plus or H3O plus, so you get this, and I measure the equilibrium constant. Okay, what is actually pKb? PKb is basically that when I have the base here, add the acid and check what is the equilibrium constant in this direction. But when I have pK, when I say what is the pK, then I have to say the other way around. That means RNH3 plus going to RNH2 and H plus. That is called pKa. So basically what is important, that lower pKa means higher
Acidity.
acidity. Lower pKa means higher acidity. That's correct. But what about the basicity? We are not talking about the basicity. We are talking about the NH2 group. Okay, NH2 group is represented as RNH3 plus, means we go in the reverse direction. This is the conjugate acid of the amine. Okay, so we will see that how quickly it dissociates into this. Okay, if this quickly dissociates into this, that means this has got higher acidity. If this equilibrium process, if this does not want to go to the right side, that means the hydrogen is tightly tied up with the nitrogen. It does not want, that means it has got lower acidity. Okay, let me again just go back. This is clear now, that pKb, when I brought pKb into picture, that if I have or the donor process, if I have this donation, when I talk about donation, then you are very comfortable that this is easier to donate than this one. So that means this is more basic than this one. This is more basic than this one. This is correct. But that means that this is more basic than this one. That means this will have lower pKa than this one. Lower pKa than this one. Again, just go back to the very basic. When I actually talk about the acidity or basicity of an amine, so this is the amine and this is the H plus. Okay. This is what is called the conjugate acid of the amine. This is the base. And this conjugate acid, this dissociation means I am checking the acidity of this NH3 plus. Acidity of this NH3 plus. Okay. Acidity of the NH3 plus, if it is, if I think, okay, give this type of problem. If I have R1 NH3 plus versus R2 NH3 plus, okay, another amine, okay, and then so this is R1, this is R2 NH2 plus. R2 means it is actually means a nature of group, R2 NH2 and H plus. Okay, suppose this has got a pKa of, just for the sake of an example, 7.5 pKa, and this has got a pKa of 9.5. Okay, now if I ask which one is more acidic, this one or that one?
The first one.
First one, correct? Okay, so that immediately tells you that means this one, if this conjugate acid is stronger than the conjugate acid of this one, Then for basicity, it will be just the reverse. That means the basicity of this is more than the basicity of this one, is more compared to that one. So what I am saying, if I have two molecules, if I say that this is more acidic than B, that means I can also say in the reverse direction that its conjugate base will be more basic than that of A. Okay, that if you look at the, if you have access to the internet right now, can you see if I ask you to see something? You have
Yes.
internet access. Okay, just type lysine. Type lysine, this amino acid, which has got an amine here, CO2H here, and 1, 2, 3, 4, 5, one more, huh? NH2. Now type pKa of lysine. pKa of lysine. You have to give me the values. pKa of lysine.
2.16.
No, that is one. There will be three pKas now. One for this one, and one for this conjugate acid of this NH3 plus. Another is the conjugate acid of this NH3 plus. So there will be three values if you look at the table correctly. pKa of lysine. One pKa is 2 point something, you said. 2 point how much? 2 point, again please. What did you say?
2.16.
2.16. Then there will be another pKa. Is it not given?
So 9.06.
There will be a third one.
So 10.54.
Okay. So what are these three? You have to identify. 10.54. I think that will be a good exercise. Okay. So the first one is basically the most strongly acidic. The trick is first you have to write the conjugate acid of the amines. We are writing not in NH2. We are writing as NH3 plus. That is the conjugate acid. So we are thinking that there are three acid groups here. So this can be lost as a hydrogen. This can be lost as a hydrogen. This can be lost as a hydrogen. So the first pKa 2.16, that belongs to the carboxy. This is the most acidic hydrogen. Now let us compare that with acetic acid. What is acetic acid? 4.7. So you see this becomes so much acidic as compared to acetic acid. That means alpha amino acids, the carboxylic acid group is stronger acid as compared to an aliphatic amino acid, aliphatic acid. Okay, so that is clear. Now come to the other two pKs. Okay, pK2 and pK3. Acha, because of the electron withdrawing group of because of the electron withdrawing nature of the carboxylic group, okay, electron withdrawing nature of the carboxylic group. So what will happen now? Which one will be more acidic? This NH3 plus will lose the hydrogen readily, or this NH3 plus? Electron withdrawing character diminishes as the length increases, right? So which NH3 plus is feeling the most, the withdrawing effect of the carboxylic acid more? This one or that one? Which amine, means in the NH3 plus, ammonium ion, is feeling the withdrawing effect of the carboxylic group more? This one or that one?
First one, sir.
First one means this one, right? So that means this will be more acidic because this electron withdrawing group makes it more acidic. So the next pKa will be which one? Will be for this one, 9.06. So that will be 9.06. And the last one is 10.54. Okay. So we have, now we have a scale that this is most acidic, followed by this one, and followed by that one. Now if I ask you which is the most basic, which is the most basic. NH. When I talk about base, I have to take the hydrogens out. That means I have to write the structure as this: NH2 CO minus and NH2. I have to write the conjugate base of all this. So I have to write the NH2. I have to write this as NH2, and this is at CO2 minus. Now the question is reverse. That if I add a hydrogen H plus, which of these three will pick up the hydrogen first? That means we are talking about the basicity now. Which is most basic amongst these three groups?
Sir, NH2, which is far from CO group.
NH2 group, which is far from CO2H. That is correct, because also the value says that, as I said, that if pKa is more, if pKa is more, that means it is less acidic but more basic. If pKa is like this one, we can say that this is less acidic but more basic than this one, whatever group we are considering here. So that means this amine is the most basic amine. This is less basic, and this is actually the last one. Carboxylate is actually the other way around. Carboxylic acid is strongly acidic. So, but anyway, if I consider basicity, this is the least basic. That will have the least tendency to pick up a hydrogen. Okay, and which is reflected by pK values, because the table always gives the pKa values. Okay, so always remember that if pKb and pKa are basically, they go in the reverse direction. One which has a higher pKa, that will be more basic than something which will have a lower pKa. Okay, so that is our ultimate conclusion, is that in amino acid, the alpha amino group is less basic than the amine group in the side chain. Actually, it is also less basic compared to any aliphatic amine without any carboxy. Without any carboxy, it is less basic. If you just type in the internet that pKa of ethylamine, anybody type pKa of ethylamine? Ethylamine, is it given?
10.7, sir.
10.7, say. So pKa of this is 10.7, pKa of this alpha amino acid is 9.06. So which is more basic? So obviously this is more basic now.
Yes, sir.
Okay, so is that clear? That means for alpha amino acids, the carboxy becomes stronger as an acid. The amine becomes a weaker base as compared to an aliphatic amine. And the side chain behaves like the normal. See, the side chain is not affected. Nah? This was 10.54 earlier, and now it is slightly affected, but not much. 10.54, 10.7. So very close. Okay. So now go back to that question. I think that will be, where is the question? Yes. So which amine is most basic? Tell me. A, C, A, B, C, D.
C, sir.
C. Is it C or B? Which amine is most basic? Yes, you said C. Yes, C. Because of the presence of the carboxy as close as amine will reduce the basicity. So this will be, you are not seeing the cursor, I think. No? So again, no, not this one. Let me find out this one. Yeah. Okay. So basically, this is, the question is NH2 here. One compound is this one, if I remember it correctly. Another compound, you put another carboxy group, like this one. A third compound is there where there is NH2 CO2H, and then this one, is it? And the fourth compound was there where there is NH2 CO2H. So here there is, this is the most basic of all these. That is clear? Okay. So
Yes, sir.
this type of, so that was the question. Okay. So let us go back to the question again. Any other question from here which is you are having difficulty?
So
One, sir.
question number 7.
One or something first. Let us go to the one. Somebody said one. Is it?
Yes, sir.
Acha, this one. The net charge of the peptide at acha, peptide. What is the peptide? Peptide is K is what? Acha, you remember KLIDE because I have to write it there. No? KLIDE. 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 Huh? KLIDE and the at pH 7. What is the net charge? Okay. What is K? K is NH2 CO2H and then a side chain which has got K is lysine which has got NH2. Okay. So that is your first amino acid. Then this is not CO2H, CONH. Then you have lysine. Then you have, sorry, leucine. This is called leucine. Leucine actually has only a, I think this is leucine, only a hydrophobic part, no functional group. So you continue CONH. So then you have isoleucine. Isoleucine is very similar to leucine. If I remember it correctly, I may be a little bit wrong in writing the structure of isoleucine. I think one is ethyl, another is methyl. That is what is isoleucine. But anyway, this does not have any functional group, any acid or basic group. So continue writing. Then you have D. What is D? What is D? Which amino acid is D? Aspartic acid. That has got aspartic acid, carboxylic acid. Yeah. Then CO, then NH, then the last E. What is E?
Glutamic acid.
Glutamic acid. Good. So glutamic acid. So NH, CONH, and at the last there will be a CO2H, and here glutamic acid CO2H. Now at pH 7, so now you have some approximate idea that what are the pKa's of all these amines. Now that was 10 point something. Just now we have done 10.5. This was 9 point something, 9.06 or something you said. Okay, so these we'll have to pick out the groups which are acidic, or basic groups, like which has got pKa's. Like when I say it has got a pK of 10.5, I am thinking of this is NH3 plus going into NH2. Okay, it has got a 10.5. This has got 9.06. Any other here? No, this is, I don't know, side. I mean nothing here. Okay, this has got a pK of what? This is normal carboxylic acid. So I might say that this will be around aspartic acid. Aspartic acid, suppose it is about 3. Let us assume. Okay. What is this one? This was 2 point something. Alpha amino acid, we have just done that. Alpha amino acid is some 2.3 or something. 2.1. Okay, 2.1. Actually, that doesn't matter. Even if you write 2, that is okay. Even if you write 3, that is also okay. And this one will be around what? 4. This will be like an aliphatic acid. So this is the pKa's we have to consider. Now our pH is at what? pH 7. So at pH 7, what will happen? Something which has not reached the pKa yet, that will mostly be present as NH3 plus, as the acid, as the conjugate acid or the acid functionality. The moment you cross the pKa, then the major portion goes into the anionic form, okay, or the lone pair, free lone pair. This is clear that if something has a pKa here, So if you go to the left side, so that will be present in the protonated form. If you cross the pKa, that will be present as deprotonated form. So if it is a carboxylic acid we are talking about, so that will be CO2H on this side and COO minus on this side. If it is NH3 plus on this side, then NH2 on this side. This has to be clear. So in pH 7, this amine will be present as NH3 plus. This amine will also be present as NH3 plus because that is its pKa is 9. So you have not reached that pH yet. What about this one? What will be the form of this carboxylic acid group at pH 7? Quick, should not take much time. Tell me, what will be the form of the carboxylic acid? Will it be CO2H or CO2 minus? You have to think of the pKa. The pKa is 3 and your pH is way beyond pKa. That means you have crossed this. You have went to the deep protection side, deep protonation side. So not deep protection, deep protonation side. So this will be present as what? Please tell me. Huh?
CO minus.
CO minus. So this will be present as CO minus. What about this one? This is 2.1. pH CO minus, and that will be also CO minus. So all the carboxylic acid groups, because their pKa is much less than 7, so they will be all present in minus forms. Okay, and the amine groups, all the amine groups are present as plus forms, NH3 plus, NH3 plus. So now you calculate the charge. So net charge is what? There are 3 minuses and 2 pluses. So the net charge is plus or minus, minus 1. So net charge is minus 1. So is there any answer like that?
Yes, sir.
Minus 1. So this is the answer, D. Is that clear to everybody? If you
Yes,
Yes, sir.
okay, so I think now it is clear. Once you had those values, that made it much more clear. Which one is the next one?
The seventh question.
7th. Okay. The group where each amino acid has got a negative charge at pH 4.0. Okay, a similar type of question. Huh? So you have to aspartic acid and glutamine. So the group where each amino acid has a group means actually this is the group. One group is aspartic acid and glutamine. So whether each amino acid has a negative charge at pH 4.0 or not, that is the question. Okay, so let us try to find out aspartic acid. You can write it down. See what will happen to aspartic acid at pH 4.0. Oh, that is little bit difficult. Now, aspartic acid, what is the pKa? I should not have given this question because aspartic acid. Uh, of course, you can always exclude A because glutamine. In glutamine, you have a CONH2 in the side chain. Huh? You have a CONH2 in the side chain. So there is no question of acidity, basicity is ruled out there. So at pH 4.0, it will be present as NH3 plus mostly and CO2 minus. Okay, let's see whether we can see both the screens at the same time. Yeah, I think this is okay. We want to see both the screens at the same time. No. Oh, that only moves. Sorry. How to? Yes. Right. Okay. So the question is, first group is aspartic acid and glutamine. What is the alphabet for glutamine? Do you remember what is the alphabet used for glutamine? A, B,
Sir,
C, D.
Q.
Q, right. This is Q and this is D. Acha, pK of aspartic acid. So aspartic acid is CO2H, NH2, and then CO2H. This pK will be close to 2 point whatever you have said. Can anybody tell from the internet what is the pK?
1.19.
It is 1.19, because it is actually feeling the electron withdrawing effect of this carboxylic acid group also. That's why this goes even further down. So this is strongly acidic.
So 1.99.
1.9. Anyway, that is still higher. This one, then there is another pK which is 3 point or 2 point something. What is? There are other pK. There will be 3 pKs here. One is 1.99. This one. Then, are you not getting it? pK of the side chain carboxylic acid.
9.6 and
Now 9.6 is this one, NH2. Eh? This one, the other one. 9.6, 1.99. There will be some, it will be about 3 point, maybe close to
3.65.
3 point,
3.65.
3.65. So this is what is the case, 3.65. Okay. So at pH 4, what will be the status of this compound? So this will be CO2 minus mostly, because you have crossed pH 4, you have crossed the pKa. This will be CO2 minus, and that will be NH3 plus. What is the question? Has a net negative charge. This has got a net negative charge. But what is glutamine? Glutamine is glutamic acid, but that is actually amide. Glutamic acid is CO2H, and in case of glutamine, that is CONH2. Okay, so at pH 4, this will be NH3 plus, and that will be CO2 minus, because this will be somewhere close to this 2. So what is the net charge here? In Q, what is the net charge? This does not have any charge. This is CO2 minus, this is NH3 plus, so 0. Net charge is 0. The question is that each amino acid in the group has a negative charge. Here, aspartic acid is okay, but not the other one. Okay, so first one is gone. First one is not the answer. What about the second one? Arginine and histidine. Arginine and histidine. What is the structure of arginine? Even if you don't know the structure of arginine very well, say basic group is here, basically. Strongly basic group. So that means somewhere some basic group, of course, let us write them. This is NH, NH2, and there is another NH. I have to forget. This is NH2, CO2H, N, double bond C, no, NH, C, double bond NH, NH2. Okay, this is a very strongly basic compound. So at pH 4, this will be minus, CO2 minus, this will be plus, and what about this one? This will also be plus. Protonation actually takes place at the double bond nitrogen. So what is the overall charge? Overall charge is plus 1. So this group is also out. Arginine, histidine. You don't have to consider histidine. If one is not matching, then no point in going to the other one. Cysteine and methionine. I think that is also gone. Cysteine and methionine will have 0 charge, because any amino acid without any basic or acidic group here will be present as this at pH 4. Okay, so it will have 0 negative charge. Aspartic acid and glutamic acid. Yeah, that is the answer. Na? Aspartic acid and glutamic acid. So aspartic acid is this. So at pH 4, this will be NH3 plus, this will be minus, and this will be minus. For glutamic acid, one more. So CO2 minus, NH3 plus, CO2 minus. So in both the cases, it has got a -1 charge. Is it now clear?
Yes, sir.
Okay, so
Yes.
D is the correct
Yes,
answer.
sir.
Okay. Any other?
No, sir.
No.
No, sir.
Very good. So you practice this type of problems, huh? We have to take a basically an MCQ type quiz. We have to fix the time now. That there will be a 10-mark MCQ type quiz on this. Whatever topics we had, we have covered. Uh, that MCQ question exam. When should we take? Today is what? Thursday. You want it on Sunday? It will be on MS Team. It will be just 1 hour exam. 10 questions MCQ type. So if I fix it on Sunday, will there be any problem?
No, sir, not on Sunday.
Sunday is okay. But
No,
what
sir.
time? No, it's not a good day.
Good, sir.
The next Thursday.
Next Thursday. Next
Yes,
Thursday. Okay. Next Thursday. I have no problem. Next Thursday. So let us write it so that it next Thursday. That means what is the date? Is today is 8th. So 15th. Huh? 15th. That is the Bengali New Year. Okay. Next Thursday. 15th of April. What time? 4 to 5.
yes, sir.
So 15th April 4 to 5. I will upload the question before that, but that can be only seen at the particular time. I will do that. Okay.
Okay, sir.
15th April 4 to 5 p.m. Remember that. And just before I conclude, just one more
Sir,
thing.
syllabus.
Syllabus for this exam.
Yes, sir.
Okay, let us go to the syllabus now. Then I have to cross this out. This I was using the whiteboard, so let me yeah, share desktop, and now the syllabus. So this was your syllabus. So I can say that you exclude some things. Okay, you can actually exclude these examples, and you can exclude. You can start from Merrifield solid phase, protection, deprotection, depression, racemization, solution, and solid phase. Okay, so that part is not there. Okay, and proteins, definition, structure, primary, secondary, quaternary. An example. Uh, you can actually, for the exam, you can exclude this part. Okay, and behavior of proteins in solution, salting in, salting out, denaturation, renaturation. Actually, this I may not have said much about denaturation or renaturation. Means proteins. What is denatured protein? Quick answer. What is a denatured protein?
So, protein that is not in natural form.
Protein that is not in the native
Activate
form.
biology.
Yes,
Uh,
sir.
yeah, proteins which are not in, which is not folded properly. Means there are many ways of saying that.
Yes,
Or proteins which are not folded properly, proteins which are not in the native form. Okay, or proteins which are active, like catalytically active, that loses its activity. That is the consequence. or losing the native structure, that the function goes off. Whatever function it is doing, whether it is a catalyst, it's a hormone, or whatever it is. So this unfolding or denaturation uh, basically kills the activity of the protein. Now, some of this denaturation can be done by several ways. By increasing the temperature. As you increase the temperature, slowly there will be more kinetic energy given to the protein, and so it will ultimately the hydrogen bonds will break, which holds the structure, electrostatic bonds, the hydrophobic interactions. So that will break and ultimately it will unfold. So that is one way, heating, raising the temperature. The other is that adding a quick way is adding SDS. You know that SDS page, electrophoresis, SDS, yeah. So that actually disrupts the protein structure. Okay. And so you can add the salts like SDS that will denature the protein. There is another way, very classic way, is to add urea. Urea also denatures the protein. And in those cases, if you remove the urea, if you manage to remove the urea, then it can again refold. Okay. So that is what is called renaturation. Denaturation means unfolding, and renaturation means refolding. Okay. Now this unfolding and refolding, whether that is reversible, if it is reversible, then it's okay. Then you can always get back. This is inactive, functionally inactive, and this is the active. So you can always get back the active form if it is reversible. But if it is irreversible, that refolding, if you destroy the folding, unfolds, and then if it cannot be brought back to the original state, that native state, then we call that this is an irreversible denaturation. The classic example I told you is that egg white. When you boil an egg, the protein is denatured, and it's
Yes, sir.
permanently denatured. Okay. So again, coming back to the course, denaturation, renaturation. I think few things. This absorbance I didn't tell also much, that proteins. Uh, this also we can have a very quick one line, two line discussion. Proteins, there are 20 amino acids. Which amino acids have chromophore? What is a chromophore? What is meant by a chromophore? What is meant by a chromophore? Chromophore is a group which
Colors.
can, yeah, chromophore and color actually they are, yeah, tied together. That's right. Uh, Chromophore is that functionality present in a molecule which absorbs the light. Whether it gives color, that depends whether it is absorbing uh, visible light. Because many compounds are not colored, so they can absorb in UV light. So we don't see color in them. But some compounds are there which absorbs in the visible light, so we get color in those compounds. Okay. So uh, so now for absorption of light, you need a chromophore in the molecule. Chromophores are typical chromophores are what? Double bonds like CC double bonds, aromatic rings, carbonyl group. Because when light is absorbed, electrons excite from the ground state to the excited level. Okay. So you need weaker bonds to do that. You understand this point. If you have very strong bonds, then you cannot excite the electrons. Excitation of electron means you are actually breaking the bonds. You are polarizing the bonds. Okay, breaking the bond will be difficult. So the weaker bonds can absorb light very easily and go to the higher excited level easily. Like compounds with many double bonds. If a compound has many double bonds in conjugation, then it is very easy to excite the electron from the ground level to the excited level. And the compound becomes, the more easy the excitation, that there is a chance that the compound will be colored. Easy means actually the gap, the ground state and the excited level gap is less. So if the gap is less, so you will reach the visible region in that case. Okay. But anyway, this is what is called chromophore. Chromophore is that part of the molecule which absorbs the light. Okay. So these 20 amino acids are there. So which amino acid will absorb light? Which amino acids have chromophore? Remember, chromophore will be there in R. If it is there at all, that has to be in the group R. So which amino acids have groups with unsaturation, with double bonds, especially carbon-carbon double bonds, because CC double bonds are the easy to excite. There are 3 amino acids like that. Which amino acids? There are aromatic amino acids. Aromatic amino acids are there. So the aromatic groups have lot of double bonds. So they will actually absorb the light. Okay. The aromatic amino acids will absorb the, where is that, where I am writing? Yes, will absorb the light. So there are 3 aromatic amino acids: phenylalanine, tyrosine, tryptophan. Out of these are the more strongly absorbing groups, because if you write the structure, this is simple benzene. Tyrosine has a hydroxy here, so you are more conjugated than phenylalanine, and tryptophan has an indole moiety. Tryptophan has an indole moiety like this. Okay, so these are the main two groups, tyrosine and tryptophan. They absorb light. At what wavelength? Because proteins are usually not colored, so they absorb at a wavelength of 280 nanometer. Okay, so the absorption, so if you want to measure the concentration of a protein, so you have to measure the absorption at 280 nm. That what is the absorbance. Okay, and that is directly connected to epsilon Cl. So if you know how many tyrosines are there, how many tryptophan are there, you can actually estimate the protein by measuring at 280 nanometer. Okay, so that is what is basically the absorbance in proteins. So absorbance and proteins, first you have to say that there are chromophoric amino acids which are tyrosine and tryptophan mainly, and to a slight extent phenylalanine. These 3. So these 3 are the chromophores, and they can absorb, and the absorption takes place at around 280 nanometer. Okay, and if you want to measure the concentration of a protein, if you know the number of tyrosines or tryptophan or the phenylalanine present, you can calculate the concentration. Again, I repeat that out of these, again, phenylalanine is a weak chromophore. Okay, but these are the strong chromophore, which can absorb much to a greater extent than phenylalanine. So the course now is very clear. The course is basically you exclude this part, you exclude that part, and you exclude this part. Okay. So your life is made simpler. Your life now is no problem.
Okay, sir.
Okay. So we have decided it will be on 15th. It will be an MCQ pattern, and this is the course content. Okay. The course content will be this. So this is crossed out. this is crossed out, and this is crossed out, and this is crossed out. Okay. Okay. So any other point? Otherwise, we'll close, and then um, we'll have no more classes except the class test. So that is fine, huh?
Yes, sir.
Okay, okay.
Yes.
So thank you very much for attending this course. And it would have been nice if it was again offline mode. Uh, but anyway, this is the best way that we can take the classes. Huh? Take care, because things are now again going very bad. Uh, so always wear the mask, social distance, all these things you maintain. I don't know about the vaccine program. Your institute is having any vaccine program for the students?
No, sir, not yet.
Not yet. Yeah, but maybe I think in near future, I think campus, the institutes which are in campus, there's there is a now suggestion that the students and the who are the residents in the campus, they will be vaccinated. Okay, but anyway, even if you are vaccinated, you have to still be careful. Like I have one vaccine up till now, the next one I am waiting. But anyway, still nobody knows how much protection it is going to give. They say 90%, some say 80%, but anyway, there is still 10 to 20% chance of getting the infection. But for you, you have to be extremely careful. Hmm? Okay, I think
Okay, sir.
so. We say goodbye for that. Yeah, you want to say something? I could not hear. That is background.
Thank you so much.
Thank you.
Thank you, sir.
If you have any problem in between, anything which you could not understand, yeah, now I will request you to go to that NPTEL course. You can read that peptide chemistry, the solid phase synthesis, everything is there in the NPTEL course offered by me. I told you earlier, na? Organic chemistry in biology and drug development. So the first few lectures will be only on proteins, peptides, amino acids. Go through that, you will get all these things there. Huh?
Okay, sir.
But can I upload this? Which PPT? This one. Now the whiteboard.
One that you were teaching. Whiteboard में audio.
Which one actually you are talking about? That whiteboard one. Is it saved? That should be saved
No,
there.
sir,
No?
the one that.
This one.
So the whiteboard has shown like there is no audio in whiteboard, even the recorded video.
Okay.
There is no video for whiteboard. So if
Oh,
at least you can upload the PPT.
the PPT.
Yes, sir.
Okay. Okay. Let me see. I'll do that. Where it is. Where is that page? I want a. So I have to go to the MS Team, but I am not finding out that particular page where I do the loading. Acha, I can stop the recording now. Stop recording. Acha. Okay.